The bulkhead pattern in software architecture is inspired by ships. What happens if a ship gets a hole? The ship will sink, right? But ships are designed with bulkheads, which divide the ship into multiple watertight compartments. So if one part of the ship is damaged, only that compartment fills with water, and the water doesn't spread to the rest of the ship. This prevents the entire ship from sinking. But what is the bulkhead pattern in programming? Just like ships, we divide the software into separate fault-isolated compartments. Why? So the failures in one area don't take the whole system down. Let's see a programming scenario. This is our monolith. Suppose there is a non-reproducible bug that, when triggered, starts an infinite loop. What will happen? It could consume all the CPU and bring the entire system down. How to fix it? We can use bulkheads. Let's divide the system into multiple individual services. Now imagine the same bug happens again. Suppose it happens in service A. What will happen? The service will fail, but the rest of the system will keep functioning. Try to visualize this through a responsive UI with multiple sections. Requests from different sections are served from different services. Since service A is down, the corresponding section will remain empty or non-functional, but the rest of the system will continue to work normally. The system is only experiencing a minor degradation, while in the previous design, the same bug had taken the whole system down. See, that's how bulkheads prevent the whole ship from sinking. But what if there is an error in the database, or one of the services overuses the database and brings it down? What will happen? Now all our services, since they directly depend on the same database, will fail too, taking the whole system down again. How will you fix it? We can fix this by giving each service its own dedicated database. Now, if one service overuses its own database, the other services won't be affected. Our bulkheads are restored again. So what's the key idea here to achieve bulkheads in programming? It's simple. Instead of sharing resources, dedicate separate resources to each component. This ensures that failures in one component are contained and do not spread to others. And that's exactly what we have done so far. First, we only isolated compute resources and got the fault isolation at only compute level. Next, we moved to separate databases and we were able to isolate database faults as well. And the same idea keeps applying. There may be other shared resources too, like a shared storage. If needed, you can split that too and isolate storage related faults as well. Now the question is, at what level should we implement bulkheads? This, or this? The answer is, it depends what types of faults you need to contain. And that's not the only decision we have to make. These things often lead to two extremes. On one side, we have developers and architects who become fascinated with the idea and are eager to apply it in real projects. On the other end, there are developers and architects who can see that it comes with a cost. It adds complexity and requires effort. So they label it over-engineering and reject the idea altogether. And this leaves many people confused. Should we use it or not? And that's where software architecture comes in. That's exactly what software architecture is all about. Decision making. Yes, implementing bulkheads comes with a cost. But if the cost of failure is higher than the cost of bulkheads, then it may make sense to use them. Otherwise, it may not. Let me show you some real use cases. Think about mission critical services. Suppose we have a project and our main mission critical services must always be up and running. Let's say it has an SLA of 5 nines. If it goes down even for a few minutes, we lose revenue and customer trust. In the same product, we also have many other supporting functionalities. They're also important, but if they are unavailable for a short time, it's not as critical as the main service. Now imagine notifications start spiking, sometimes bringing the whole system down. And occasionally payments spike as well. In such cases, we can move those areas into separate bulkheads. So if a failure happens, notifications may stop working or payments may temporarily fail. But the main system remains up and running. Or we can design it the other way around, keeping the mission critical services in one bulkhead and everything else in another. By isolating the mission critical area itself, we prevent even unknown or future failures from spreading into it. To better appreciate how powerful this idea of isolating mission critical services can be, let's see a few examples. Take YouTube. The videos are playing fine, but the comments area is unavailable. The comments area is also important, but YouTube mainly earns from videos and ads. Think of an e-commerce website. You can still browse products and complete your payments, but the products reviews section fails to load. Imagine a banking app. You can check your balance and do transactions, but The transaction history and some other analytics features are temporarily down. Isolating mission critical services in high availability systems, that's a primary use case of bulkhead pattern. In addition, bulkheads are also useful in many other situations as well. For example, we can use bulkheads to prevent background jobs from exhausting system resources. So batch processing does not slow down user-facing requests. They can be used to contain known buggy components or isolate experimental work. In multi-tenant systems, they can isolate tenants, ensuring one customer's heavy load does not degrade the experience for others. You can also use bulkheads to isolate security concerns. If one component gets compromised, the breach stays contained and does not spread across the entire system. Another interesting bulkhead example in real systems is reporting. Teams often build separate services and databases for reporting. They usually do this because reporting has different data design and performance requirements. But as a result, it naturally creates a bulkhead. This means that heavy usage or problems in the reporting system do not affect the main transactional functionality of the application. Finally, bulkheads provide a very strong form of fault isolation, but they also come with a higher cost. So they should only be used when they are truly needed. There are also some other architectural patterns and tactics that can be used as an alternate approach in similar scenarios, such as circuit breaker and graceful degradation. It's also important to understand that much of architectural decision making comes from knowing the alternate ways to solve the same problem and understanding their trade offs. Check out the top comment for the further details.